We will discuss about this video the integrating factor. So first of all, we have to know that what is integrating factor. An integrating factor is a term or function which makes a non-exact differential equation to exact differential equation. And here we will discuss that how to find the integrating factor of the linear differential equation, or the mostly known as this term, that is dy dx plus p of xy is equal to q of x. So basically this equation is a first order and first degree equation. First order and first degree equation. First degree equation. So now how can we find the integrating factor of this linear differential equation? So first of all, we make it in the symmetrical form, that is dy plus p of xy minus q of x dx is equal to 0. And what is integrating factor? Actually, we multiplied the integrating factor in the given non-exact differential equation, whereas this is the given differential equation dy plus p of xy minus q of x dx is equal to 0 in the symmetrical form. So here we consider that let r be an integrating factor of this equation. So before going to find the integrating factor, just follow this line, that since this is the term dy plus p of xy dx minus q of x dx, see here this part we can easily integrate this, or actually we can solve it by the separation of variable, or we can say this is easily integrable. So we just now take for finding the integrating factor this part, that is now we write that is dy plus p of xy dx is equal to 0. So now what is the now we multiply, that is suitable, that we choose that r be the integrating factor of this equation. Let us check that how can we find the r, or how can we find the integrating factor of the linear differential equation. Okay, let us try to find the value of r. So here if we multiply by r, what we get? R dy plus p of x ry dx is equal to 0. And now this will be now in the form m dx plus n dy is equal to 0. And now this will be exact equation after multiplying the integrating factor, that is if del m del y is equal to del n del x. So here we see here that if we consider this equation with m dx plus n dy is equal to 0, that is m is equal to p of x ry and n is equal to r. So what we get here, that is del m del y is equal to p of x into r, and del n del x is equal to del r del x. And so from here we can write that dr dx is equal to p of x into r, and whereas if we just simplify here, dr by r is equal to p of x dx, and then we get r is equal to e to the power integration p of x dx. So now we can say that for the first order and first degree equation, or the linear equation of first degree, the integrating factor of this equation dy dx plus p of x is equal to q of x is e to the power integration p of x dx. So now if we multiply it by now here e to the power integration p of x dx, we can say that this equation is exact. So this equation is exact. So we can say that the integrating factor of the linear differential equation dy dx plus p of x is equal to q of x is e to the power integration p of x dx. Thank you.